So welcome back guys, this is Madhav PVL and today we are going to discuss about this first topics in this course outcome 2, that is operating systems and organization. So let us just discuss about this each of its topic, and basically we need to just remember this one point. This one point plays a crucial role in the life of a operating system. So basically user requirement is most important. So user requirement must be the first priority for anyone to just create an operating system. So this is a statement which is belonging to that. So user requirement is the most important. So these are the contents which I am going to just deliver today. So the operating system organization, context of a process states and transitions. Those three will be in one video, and the kernel data structures and sleep and wake up will be in the another video. So basically let us just get into this first one, operating system organization. So what is operating system organization? So operating system organization is nothing but in which way the approach is going for the user. So approach in the sense, so in which way the user can just access this operating system. So basically there are two ways. There are command line interface and graphical user interface. So command line interface is nothing but we need to just provide a command and this command prompt. In the graphical user interface we need to just click on this graphical symbols to just execute our file. So basically these are the two fundamental approaches for the users. Provide command line interpreter CLI allows user to interface with the graphical icons, that is GUI. So CLI is entering command and command prompt with system calls, that is Linux, and then GUI is clicking on graphical icons, that is Windows operating system. Now let us just get into this command interpreter. So command interpreter is a special program in Windows. Multiple command interpreters are known as shells, so this we will discuss in the further topics. But command interpreter is a special program in Windows. This is because Windows is just providing this graphical icons, right? But command interpreter is not much used in this Windows operating system. Only the people who requires them, who need to just learn the code, he will just use this command prompt in this Windows operating system. But it is providing this graphical user interface, then no need of this command interpreter. So what is graphical user interface? It is well known to everyone. Graphical icons which are used to run this executable files. If we just click on that icon, then this file gets executed. So that is about organization of operating system. And then context of a process. So context of a process is nothing but when we just run an executable file, then the operating system need to create a process. So process is nothing but if we need to just do some work, there will be certain steps to follow, right? So those certain steps are known as a process. So if we just run an executable file, then operating system will create a process. So OS has a CPU scheduler that executes on a CPU. So CPU scheduler is nothing but it will just create a process for opening a file and running some things. So for running some things in this operating system, CPU scheduler helps to execute on a CPU. Then the CPU scheduler have two parts, that is policy and mechanism. So policy is nothing but it decides the instructions to just work on this process. So the instructions will be just decided by this process, whereas in the case of mechanism, this whole so those instructions gets executed in this mechanism part. So policy is nothing but it will just pass the instructions, whereas in the part of mechanism this whole process will just get executed. So this is about process abstraction. So basically we need to know some requirement like what does a process contain. So to execute a process we need to have some basic requirements, right? So some of the basic requirements are a unique identifier. So unique identifier in the sense we can just consider it as our roll number or an admission number. So whatever it may be, if we just study in some college, so that roll number which is assigned to you will not be changed for any others. It will be a unique one for yourself, right? So this unique identifier is nothing but just simply like a roll number. So it will just assign a number to a file or an application which is belonging to some directory, so that identifier will depend upon some of these conditions. So it will just keep a unique identifier for each and every file for just the process of identification, whereas the file descriptors are the pointers to open files and devices. So these file descriptors will be mainly in this cache memory. So in this cache memory, these file descriptors will be present. So these are the pointers, that is nothing but the addresses to open these files and devices. So the addresses to open these files and devices will be stored as a pointers in this file descriptors in this cache memory. Whereas if we just come into the CPU context, then there will be registers. So the registers doesn't only belong to this memory registers. So different types of things are known as this registers, like program counters. This is used for the signal purpose. Current operands in the sense, let us just consider an example. In the case of a plus b, here a and b are the operands and plus is the operator. So basically operands are nothing but things which are required to just execute a file or just run a program. That is known as an operand. Whereas the stack pointer is nothing but the stack which is built in the middle of the program. So stack in the sense, stack is used to just stack is just used for this arrangement of a program in a proper order. Like if we need to just change from one place to another, we need to just take that application in the form of a stack, and we need to just change them with some techniques. So stack pointer is a dynamic, so it will just build there itself. Whereas the memory images are this code and data. So code and data are static because we will just produce this. So code will be given by the user and data also will be given by the user in the form of this input format. Whereas the stack and heap will be dynamic, to just it is just used for the purpose of this movement of the data. So stack and heap are dynamic because that is produced by this operating system. So how does a OS create a process? So it allocates memory and create a memory image. So to create a process, there are certain steps, right? So it will just load the code and also the data from the disk. So let us just consider the data which is required to run this code is present in the secondary memory. Then the data will be read from the disk in this second step. And then the third is creates a runtime stack and heap. So the stack and heap is for the purpose of getting a structured program. So it loads the code and it also loads the data from the disk, and it creates the runtime stack and heap, and it also opens the basic files like standard files, input files, output files, and error files. So it also opens these basic files, and it initializes the CPU registers PC points to first instruction. So the first instruction will be passed on by this CPU with the help of this PC program controller, and then these are the steps to just create a process. So process states and transitions. So process states are nothing but so every process will be in certain states like running state, ready state, blocked state, new, and dead. So there should be some place or like some condition, right? So every process will not be in this running state, some will be in some other states, right? So let us just consider this kernel is receiving 5 processes, then one process will be in the form of running, and remaining 4, let us just consider this 4 processes. So running is nothing but currently executing process is known as a running state, and then ready state is nothing but the process which got all the permissions and it is just waiting to be scheduled is known as a ready state, and then blocked state is nothing but the process which didn't get any permissions and it is just suspended by this operating system, or it is not ready to run, then it is known as a blocked state, and then new state is being created or yet to run. So let us just consider this ready and new. These both may look similar, but new is nothing but this file is just creating now itself and it is just yet to ready. But after creating the file, it will just get ready. But ready is nothing but it is already created a long ago. Then if you just click on this running, then it will just get scheduled to just run. So ready and new will be a part different, but it will look similar. So dead is nothing but terminated. So dead and blocked are almost same. Blocked is nothing but once it will just get into this running state, and this running state will pass a error interrupt like this is not the data which I am not requesting, then it will just get blocked. So that is nothing but it is not used for this process, then it will just get terminated. So process state transition is nothing but if in the IO, so let us just consider here. So if the input is ready, then it will just get into this ready state. After it is getting into this ready state, it gets scheduled. After it is getting scheduled, it gets run. So after running these IO initiates, so after running this data which is output will just get blocked. So after getting blocked, again this input will come from this external source, and this data will be like this. Whereas in the case of deschedule, let us just discuss. So deschedule is nothing but, so if this input is given and then this input will just get into this running state. If running state throws an interrupt like error, so this is not the data which is required by me, then it will just get descheduled, and again it will just get into this ready state, and again it will just get out of this IO block. So this is about deschedule. So this is process state transition. So let us just discuss about this other two in this next video.